Hi, good morning, Secondary 2C. Thanks very much for being willing participant for today's micro teaching. We have some individuals that come from McGraw-Hill, especially Mr. Sean, who has volunteered to do a demonstration of using math resources from there. And they're going to handle a class that you've already done. This is to do with quadratics. This is to do with expressions, as well as equations, how to factorize, how to solve those. So it's stuff that you have learned. So hopefully you can benefit from this teaching, not only to enhance what you have already learned, but also see from a different point of view. Okay, so Mr. Sean, yes, to you now.
All right, good morning, everyone. Hi, my name is Sean, and nice to meet you guys today. So before I begin, can I just have a quick show of hands? How many of you love math? No one? Okay. Don't worry, after today, I think I'm going to change your minds. Okay. All right, so I think previously we talked a little bit about quadratic equations. And I just want to start off by asking you guys to think about this question. Why are we learning quadratic equations? Okay? And think about how useful is it in my life. Okay, so one of the big things that we struggle with is that why am I studying this? How is it going to impact me? Why is it useful? All right. So I want to start off with a video, and I want you to watch that video clearly, and I'm going to ask questions later. Whether you can see the usefulness of learning quadratic equations. Okay, so let's look at this video, and I'm going to try my best to share because I'm not sure whether. Okay, nice. Okay, so again, the question here is to watch this video, is to think about the usefulness of math, all right, and also in quadratic equations. Let's look at this video, and I'm going to ask some people questions. I got prizes. Okay.
Sailing your paper football through the uprights takes just the right touch. Like a real football going through the goalposts, a basketball heading for the hoop, or even a diver entering the water. The path of a paper football is a parabola. A parabola is the graph of a quadratic function. Notice some of the key features of the path of the paper football. The football reaches a maximum point in the middle of its path, and the path before that is the mirror image of the path after it. Every parabola has a maximum or minimum point, also called its vertex, and they all display symmetry around that point. While every path follows the shape of a parabola, you can change the path your football takes by changing where or how you kick it. These involve transformations of the quadratic function. If you know the quadratic function that describes the path of your football, you could complete the square to find its maximum height. And you could use the quadratic formula to find when and where your football will land. In this module, you will learn how quadratic functions and equations apply to the real world. You'll also figure out the answer to this important question. Why is it helpful to have different methods to analyze quadratic functions and solve quadratic equations? Are you ready? Let's begin.
Okay. So I'm going to give you 10 seconds, and I'd like you to think from that video. Some of you are sports people, you don't have a sports background. How can you use quadratic functions or math in that area? Okay. All right. Can I get you to turn to your partner and talk? Yeah. Turn to your partner. What do you think of video? And how can I use it I'll give you 2 minutes. Quickly share your ideas. Okay, guys, thank you for discussing. Any brave soul would like to volunteer your friend's answer or your own answer? Yeah, look, you prize answer, my friend. Nice prize. Yeah, okay, introduce yourself. Her answer is. Oh, okay. Can you explain a little bit further? How is it completely?
So like we have to take the movement where it lies. Can I go over that or?
Okay, so you're interpreting and doing right? So, but of course you need the formula. Yeah. See? So okay, so again, many of us, math is when I was studying math as well, it was struggle. But you realize that in real life, math has a lot of impact, even for sports, for badminton, or basketball. If you can understand the formula, you can predict where it is. And when we think about it further, say you talk about space, how air travels, many things, right? You can get the formula, you can predict where it goes. That's one of the most powerful things about math. All right, the predictive power. So I'm going to start off with an activity with everyone. I'm going to get you to predict something. All right, this activity is on movie tickets. All right, and we're going to see how movie tickets were the cost of movie. Do you like to watch movies?
Yeah.
Horror movies? No, maybe. Comedy, romance, K-drama. Yeah, I know. Okay, so movie tickets, all right, was some, really cheap in the past, during my time, during your teacher's time. But it's risen now. So this first activity, which I want you to discuss, again, as a pair or in your group, is to predict, all right, what's going to happen to that movie ticket. All right, so I'm going to give you now a little worksheet for you to see. Okay, but before you run dash quick answer, I want you to take a look at the question first and ask yourself, what do you notice and what do you? Okay, I'm going to give this down to you. Can you pass down to you? Anyone volunteer more, guys? All right. I have a lot of gifts to give out. And okay, can you go write your name and your class right there? And we're going to be looking at this. Okay. Thank you. All right, once you're ready, first individually first. All right, you don't have to do it as a pair first. Okay, let's look at this. It says that this table shows the price, and this is in the US. Okay, so in US dollars, how movie tickets have been changing, right? All the way from 1910, that was 100 over years ago, to 2018. That's like 6 years ago. So first thing I'd like you to write down before we jump into the answer, all right, is, can you write down what do you notice and what do you wonder? So what kind of things do you see in that table? And what kind of questions you may have? All right, so can you get it to write this out individually first? what do I see in that table? And what questions do I have? So let's write that down. You can write down more than one. You know, you don't have to write down one. As many as you can. What do you see? You can say, I see numbers. That's okay. Okay. So what do you see? And what questions do you have in your mind? Right, as you look at things, and try to see as clearly as you can. All right. Okay, so once you have, at least one, or if you cannot think of any questions, then I now get you to turn to your friend and ask, okay, what did you see? What did you see? And what kind of questions? Okay, yes, have you shared? Okay, come, let's get some. Okay, come. Who? I saw you raise your hand first. Come, what's your name first?
My name is Jaden.
Jaden.
Okay.
What do you know? Yes.
The price goes up as the years pass by.
The price goes up as the years pass by. Any more things?
There are numbers.
There are numbers. Really? Okay. Okay. All right. There are numbers. Any more things? That's it.
Yeah.
You only saw two things? Okay, good. What is your question as well?
Oh.
And your friend's one as well.
What price will it be after 10 years pass by?
Will it be after 10 years pass by? Any more?
Why does the price keep going up?
Why does the price keep going up? It's a good question. Okay. Any more? No more. Okay, well done. Okay, let's get one more student. Yeah. Oh, I love this, man. You can put like your phone and what's the name? Okay. Yes. What's the name first? Aiden.
Nathan.
Nathan. I thought Jaden, Aiden, there's so many students. Yes, Nathan.
So I noticed that the earlier the year, the higher the price of the movie tickets, and also
The earlier
the year,
the later the year.
like 2018 is earlier than 1971, so yeah, especially.
Okay, so
Earlier the year, the higher the price of the movie tickets.
the higher the prices of movie tickets. Okay, anything else?
The prices of the movie tickets are never in a whole number.
Oh,
Yeah, they're never in a whole number.
are never whole numbers. Nice. Anything else?
That's what I noticed.
Okay, what about your friend?
Huh? Yeah.
Yeah. Can you look at his answers? What did he write?
In 1970, the price don't make sense because it decreases.
In 1930, the prices don't make sense
Yeah.
because it decreases. That's nice. Because it decreases. Okay, that's good. Nice. Okay. What about the question?
Why did the price of the movie ticket drop in 1939?
Why did the price of the movie ticket drop in 1939?
And why are the prices never in a whole dollar?
Ah,
Yeah, that's
why are prices never in whole dollars? Okay, wonderful. Good job, man. Yeah, great observations. Okay, this is for you. I'm running out already. Okay, so today the question that you guys would have to try to answer, and this one also same thing will be done in your pairs. All right. And of course, later I'm going to give you some clues, but I want you to think of this question first. So let's look at one question below. What is that question? Can you read? Can someone read for me?
Will we get it right?
Sorry, I gave up on my worksheet. Ah, okay, ready, everybody? Let's read together, shall we? It's like primary school at it. Let's do this. Okay, where's my? Okay. Share this. Let's go. So today, the question that you're supposed to try to answer, and if you can give a good answer, that'd be great, is that you will work with your partner to answer this question. What will the price of the movie ticket be in 2077? Okay, so what will the price of the movie ticket be in 2027? You can see that later we will guide you through this, all right? But you cannot just say that it will be $10. All right, you need to have a reasoning behind it. So that's what I would like you to think about. How? Okay, so let's look at, I'm going to give you some time to think about this as well, and later I'm going to give you some hints. All right, but first, I want you to think together with your partner because this will be a pair work. All right, you and your partner will do it. And you got to ask yourself, hey, let's look at the problem first. What assumptions are we making? All right, and why are you making these assumptions? And what are some constraints that you need to consider? And the more important part here, which is what I really want you to share with me, is what is your model, okay, of predicting the price. Okay, is it, what is it? All right, so you have to tell me what type of model best represents the data. Then you solve that thing to actually show me how you get the answers to your price of the movie ticket in 2027. Okay, so I'm going to put up a timer. I'm going to give you 5 minutes just as a start to think first. All right, so you can look at the guiding questions that ask you, hey, what are some assumptions you're making? Yeah. And then after that, it's important that this you where you must work together with your friend because coming up with a model is very difficult. Okay, now I want to also give you a little bit of help. I want to allow you to also use the internet. All right, if you have internet, they can use the device. Okay, so you can use the device with Google. All right, if you need Google help. Okay, but you only have 5 minutes. All right, yes. All right.
What's the number of
Okay, I'm going to put out the timer. You have 5 minutes, all right, to discuss and come up with a model first. All right, it could be every year increase by $1. Okay, but what is your assumption?
more than the price looks like a bit more than match.
Okay. Okay, so you can Google if you want. All right. Well, let's hear some intelligent. All right. So think about it, and you can do your research. All right. What are some assumptions? So I heard one very good assumption. There is an anomaly. All right, that's happening. Okay. But I want you to come up with a model. All right, how you would solve this thing first. All right, what would happen in 2027? What would the price be? Okay. Okay, 5 minutes. Quickly. Discuss. Don't do it by yourself. Discuss with a friend. All right.
We don't have any.
You don't have any friends?
So I don't know about Jade and I know. I
Okay, so you must come up with a model to do all that, right? Okay.
So thank you.
The next one.
I see. Like 5 years, right? So into that, like only like some years. So let's say. This
Oh, that's Chinese.
Yeah.
Yes, you Chinese as well, right?
Oh my God. Not that. Six point two one. 6.2 why that
Yeah, look at
right
Okay, 2.5 minutes on, right? Trying to come up with a model. How would I guess? All right, the exact price of the movie ticket. Look at the data. All right, I'm trying to get. Okay. Is it increasing by $1 every year? For 10 cents every 2 years. So take a look. All right, and then from there we can.
that was just thinking
Yeah, we're not going to be there, man.
that's his idea.
Okay, what are you doing?
Oh, that's good.
Ah, yeah.
Right.
If you're looking for the answers to this worksheet online, you can't find it. Okay. Don't look for it. Okay, look at the data, right? Here's your friend talk about it, right? Is it increasing?
Ain't no way I'm moving ticket and how much does it cost? 0.46. Six point zero four. What year is that? 2006. 2008.
Okay, another 40 seconds, guys. Yeah, we just come up with an initial guess, right? And how we come to the guess. Just guess.
How much it goes up in the year. But I on the other side, more than 9.11.
Okay, time is up. Okay. All right, let's come back here, everyone. Okay, don't worry if you haven't come up with any answer because it's really a challenge. I want to start by saying that in 2027, we don't know what the COVID virus is. Okay, we don't know. What is COVID is again? Correct? And COVID virus is different. Nobody knows what COVID is. Okay, but I would like you to think about it. All right, if I look at the numbers, what could it be? All right, and what? If we're looking for a specific number, so not just more than 9,011. All right, we're looking for a specific number. Anyone, just from these 5 days, have come up with an interesting way of analyzing the data, and you have a guess, an initial guess. I'm going to give you a try later, but anyone? Go on. Anyone has an initial guess? Anybody? A way to find the answer. And then figure it out. Okay. Okay, guys, listen.
Maybe we can look at the data and calculate the average difference in price.
Okay.
You can calculate the price.
Okay, so Brian says that we can calculate the average price difference for every year, and then from there we can guess, in 10 years, correct? For 10 years, what would the price difference be? All right, look at 10 years, 10 years, 10 years. All right, okay, and maybe as a follow-up as well, do you think this price would be the same? Do you think that in 10 years it increased by, let's say, 50 cents? The next 10 years will be 50 cents. Yeah. How do you think it happens? If it's not like that, so it should be 50 cents and then $1 and then 150. Is it more and more? The difference getting hard?
Could be more and more and more.
Could be more than that. All right. So this is really something that you can see, right? You can actually find some difference. Okay. And later, if we say that every 10 years it increased by 50 cents, so 1910 to 1920 increased by 50 cents. 1920 to 1930 is 50 cents. 1930 to 1940 is 50 cents. What do we call that kind of game? Sorry? It's what? What kind of pattern?
Constant.
Constant? Or we can say it's a linear pattern, correct? It's linear, correct? So if we draw a graph, it's going to go like that. Alright? What happens if it's 50 cents and then after that, the next 10 years it becomes $1? And then after that it becomes $2. What kind of pattern do you see there? What kind of pattern does it look like? How will the graph look like? So that's not 50 cents every 10 years. Okay, but let's say as an average. Correct? As an average. If it's going faster, how will your graph look like? Steeper? Like curve like that? So what do we call this kind of graphs? Yeah. What's that? Quadratic. Wow. Yeah. So we're actually looking at quadratic graphs. If that's actually data, and we're going to look at. Okay? And so if we can actually predict, alright, that model, alright, if it is actually like that, then we can use that graph to actually solve what that we don't have. Okay? Alright, well done, Brian. Have you got one ready? No, okay. Okay, so now let's look back and I want to see how you guys, later we need to take a photo together, okay? I want to see how much you guys know about quadratic. Alright, and then we can come back and we can actually solve this. And I'll give prizes to your teachers because I don't think you can solve this. I have the answer with me. But I hope that one pair of you would actually solve it and give me the answer. Okay? Can I get you guys to see this? Okay, ready? Yes. All right. So if we can come up with a quadratic graph, if you can solve it, then we can get answer. So the hard part for you is to come up with a quadratic equation. All right. So I think you all have learned this, but I do want to see how much you guys have learned. All right. So can I get on your table something for me, please? Can I get you guys to take out these three things? All right. Can you have a calculator, a table, and a pen and paper? Right? Not worksheet, but a piece of paper. All right, almost. Okay? Because I'm going to ask you guys to show me some of your. Okay. How much do you guys want? Yes? You have a notebook or like a piece of paper? Yes. So calculator, sanitizer, and maybe can you come up if you have? Yes. Okay. So from what I know that you guys have learned from your teachers, you have learned something like this. Okay, so are you guys ready? Need your calculator a little bit. You did great. Alright, calculator ready? Okay. Nice. All the new calculators. Well, I saw some behind you ChatGPT already. Okay. All right. So from what I know that you have learned, all right, you have learned how to factorize. Okay. So for example, if we see here, you see here, all right. If we have ax plus bx, zy plus dy, we can then factorize out the x. Right? You have learned this? Okay, and then you can put them together, a plus bx plus b. Okay. Another way of factorizing is to look at quadratic trinomials. Trinomials is three terms. Right? How do we factorize these three terms? All right. If we can find this plus this, we can actually bring them together. All right. So later we will see an examples of this. A square minus b square. Have you seen that?
Yes.
It's a plus b, a minus b. So you have seen this before. Perfect squares. A square plus 2ab plus b square equals to, yes? Very good. Okay, so let me see your skills here. I have five questions for you. First, can you tell me whether you can factor? Is it possible to be factorized? All right, so there are five numbers here. Can you factorize them? And if so, can you factor it? All right, so let me see whether you can do that. Everybody do it individually first. You can write down the five expressions right here. Number 5 is a little bit challenging. All right, but I do want to see whether you can do 7%. Okay. So remember, the first step is to ask yourself, can I actually factor this? Right? And if so, then I factor it. Right? So don't just start with the factorization. Okay? Okay, you need help. So okay. They may not be able to be factorized.
Yeah.
So think that it does.
Oh, no.
Okay, just do it as whichever you go. Okay. Number 3 can be factorized. Don't have to do number 5. If you love the challenge, then 5 can do it. Okay. Let me get some. You brought the code? Okay, I can give you 2 more minutes, all right? Try to think. I know it's early in the morning. You solved it? Okay. You done forward?
Wrote the code. I wrote the code. Oh, it doesn't even work.
Okay.
Actually, what
You wrote the code for question 2. What 3?
Oh. This one is the urban key first.
I got all the one. It's supposed to create that. Number 5 is the trigger.
Okay, now number 1.
How do you find the area?
One. And then okay, number 4. Oh, it's minus and plus.
Okay, last 30 seconds. Maybe don't worry, we know how to do this. Okay. Alright. Let's see how much you know first before we look at any questions.
5. Okay, I'm talking about
You're in 5 really?
Oh, what is that? I was like, tell me this. Yeah, I want to bring the code. Trust. No joke. No joke.
No joke. Okay, time is up. All right. Anybody who is brave enough to share me your answers?
Didn't already have price.
For first 4, all right. 5, never mind. 5 is for those who have time. Nathan?
The one is so comfortable.
Sorry?
The one is so comfortable.
Number 1 is not comfortable. Number 2?
Oh, number 2 is x plus 11, x plus 8.
X plus 11, x minus 8. Okay. Number 3?
3, x minus 8, x plus 4.
X minus 8, x plus 4.
Yeah.
Yeah. And the last one?
4, x plus 3, x plus 3.
X plus 3x minus 3. Okay?
Yeah.
Yeah. Okay. Let's see.
Okay.
Yeah. Oh,
I got it, Jay.
you got it correct?
Number 5.
Yeah, sure. Let me see.
There we go. Yeah. Do you all get the same answers?
Yeah.
Okay. All right. Okay. So we can see that, guys. All right. 88 is right there, correct? From there, we can split 88 into 11 and 8. All right. We can see the difference right there. 8 plus 11 minus 8, you get 3. All right. So that's where you get how to factorize the second one. All right. The third one is the same idea, right? 8 and 4. Okay. And you can see the minus 4, we can get that as well. Okay. And the 4 point is the a square of it. Okay. Now the last one really is a question that we bring it out to something that is applied. Right? Not just a simple question. To find the area, we have to take our length and breadth, correct? So we have to take this side, multiply by this side. All right, and then we have to minus away that length square. All right, and that's how you get this x squared. And then from there we see whether we can actually factorize. Okay, so I think my clicker is not working. I'm gonna just stand here. Okay, so some of the things that we have to look at really is to be careful. All right, you have to be precise and think carefully. Look to your partner, don't worry. And of course, use those ideas that your teachers have taught you. Right, a square minus b square, things like that. Now, today we're going to learn to solve things. And before we continue, how does factorization actually help me to solve things? How does factorization actually help me to solve things? Does it actually help me?
Yeah.
Yeah, it does. How?
It simplifies.
It simplifies things and then we can solve it. Okay. And this is a little clue for you, right? Into your project as well. All right. If we can come up with something, we can factorize it, we possibly could solve it. All right, something for you to think about. Okay, so I want to share with you one simple way of solving things, which you need your calculator for. All right, so basically, if I have a simple like quadratic equation x squared equals to something, all I got to do is just square root it. Correct? And when I square root it, what happens? What happens here? I get a plus and minus. All right, because if you square two negative numbers, you get positive number. All right. So, if I get something like x squared equals to n, and n is a perfect square, then I get a nice integer answer. So 25, I get a nice plus minus 5. All right. But if I don't have that perfect square, I will then need to use my calculator. Okay. Now, can I get you guys to think about this? How would you approximate square root 30? How would the number be? Square root 30 would be what? Is it number one? Is it a perfect square? No. No. Okay. Then what would the number be? Between what and what?
6, 5 and 6.
5 and 6. Why?
It's like 5 times 5 is 25.
5 times 5 is 25. 6 times 6 is 36. So it's somewhere between 5 and 6. All right. So you should expect your number to come up somewhere between there. Okay. If I give you this equation, how will you solve it? Y plus 5 equals to 21 square, bracket square equals to 21. How would you solve it? Okay?
Make it equal to 0.
Sorry? Make it equal to 0? Why? Because you're taught by your teacher? No, you can just square root it. So y plus 5, you can square root 21, correct? You can use calculator. Yeah? Can you do that? You can square root? Yes?
Yeah.
Okay. And then y equals to negative 5 plus minus square root 21. Yes? All right. And then we can have negative 5 plus square root 21 or negative 5 minus square root. Correct? Is that one way to solve it? Yes. Okay. Make things easier. Don't be so complicated. Okay? Okay, come, everyone. I would like you to think about the solutions for A and B now. Let's go. If it's x minus 2 squared equals to 16, which one is it? Okay. And if it's y plus 18 squared equals to 77, which one is it? Is it A, B, C, D, E? Okay. Later I'm going to ask you to go to the letter. Okay, so choose a letter, all right, that you think is the correct answer, and we're going to ask you to go there. Okay, for both A and B.
That's my prize.
Okay, can you all choose a letter? All right, I'm going to ask you to walk to the letter. Okay, for question A first. Okay. Okay, are you ready? We're gonna do some movement, guys. Okay. All right. Okay, we have. Let's do a 6 corners. Okay. So if you think it's A, can I ask you to come to here and stand here? Okay. If you think it's B, can I get you to stand here and then C is there? All right. C is here. All right. If it's D, can I get you to move to the left there? The red chair right there. If it's E in the middle, and then it's F, left corner there. Okay. Are you ready? Okay. Don't trust your friends. Okay. Trust yourself. Okay. Ready? Ready? Go. Go. A is here. If you think it's A here, B is here, C is there, D is that big corner. E is in the middle. Oh, yeah, D.
It's A, right?
This is A. All right. Okay, so we have this A, or are you B? A, move to the side. Okay, so we have A. Okay, guys. E. So we have A, we have C, we have E, and we have F. Right? Okay, wait. Next job. I want you to send one person to the other side and convince him to come over. Okay, go and convince someone. Go. Send someone over and convince the person to come over. Send one person. No space for the teacher. All right, ready. Come, let's listen to the spokesperson. Okay, anyone here would like to explain why it's A? Come loud and clear to your class. Why do you think it's A?
I already explained twice.
Yeah, go ahead.
So like X. So this can actually be A and F. This is can be A and F. So if X minus 2 squared equals to 16, that means X minus 2 normally equals to 16, the square root of 16, which is 4. So X minus 2 equals 4.
Yeah.
So then X equals to 4 plus 2
4 plus 2, which is 6.
6
Also, you should bring it.
or negative 6 or negative 6
Oh,
plus minus 6.
negative. Okay. All right, come C. How would you explain?
Explain yourself, please.
Yeah, go read it. Loud and clear. Where's the loudest voice?
So like Kaylee said, she said there was 2 answers, right?
Yes.
And according to her, it's true. It's negative 6 and negative 2. For example, or negative 2, which is why we went over to negative 2 over here because her calculation could be the same.
Because the calculations are right. Okay. You can't put it right. Okay. What about it? Square root of 20 is gonna be 6. Negative 4 plus 2. Jaden says that. All right, Jaden says that I can factorize x minus 2 squared into x plus 2 x minus 2.
So really,
And then it's
Yeah,
equal
yeah,
to
yeah, benar.
Okay.
Yours.
Alright, the last one.
Yours benar.
Anyone want to share?
what's negative?
Yeah, yeah, yeah. Salah. Diam, diam.
Okay, ready? Last one. Yeah, we take that, right?
Diam. Ya, diam.
Both sides. Okay. Right, yes. Okay. Okay, wonderful. All right. So, are you convinced? Oh, you're moving. They put you on. So, only this, you're refused to move. Refuse. Okay. All right, let's put it out here, right? Ready? Oh, what do we hear? The square root. Correct? We just learned the square root. So when we square root both sides, what do we get?
Four.
Square root 16 is what? Is?
Four.
4.
So be like.
Only 4? Plus and minus 4. Right? Yes? Yes? And then x minus 2 is equals to 4 or equals to negative 4. Right? So x is equals to
6
6
and negative 4.
and
Do I have
negative 2. So answer is C
that's the last one.
and F. Okay, come. Can we just check why can't we do this? Why can't we do this? All right, because it's a good answer, correct? Why can't we do this?
Because it's too long. Takes too long.
Why can't we do this? And then we square root.
No, it's wrong.
Can we square root like that? Yeah. Okay. So we can't square root this because these are the same, right? We can't square root it. They're not the same. So we can square root this. Correct? Alright, so we can't do something like that. We can't do square root both sides here. Okay, because they're not the same thing. Okay? Alright, so well done guys, take a seat. Good job, man. Both of you. Alright, very good. Yeah. Well done, well done. Okay. Okay. All right. Actually, there's much more, but maybe just as a finish for this one, can you choose the answers for this as well? Just the last one. Let's go. Choose the last one. Yeah. You said 2 or negative 2? It's negative 2. Okay, now with the same idea, right? Can we try part B? All right, can we try part B? Right? Let's see what option we use for part B. Now I know. Okay. Are you going to do part B? All right, so y plus 18 squared equals to 7. How would we solve that?
I got it.
Yeah, I need calculator. That's nice.
I got it.
This answer.
Okay, what one do we have? Can we move to like, okay. What's the next method? Science. What time is it? 9:30. Okay, so we have 10 more minutes. Done? 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 Should I get the answer this time? Maybe.
I positively.
Positively. Okay. Positively. Positively right answers? Or you guys are very confident?
Yeah, right.
Answers? Okay. Okay, good. All right, as a class, can you all solve your answers together? Ready? 1, 2, 3. What? A and B. Okay, let's see whether you learned. Yeah. You guys awesome. Okay. All right. There's one more thing. All right. So this was one of the ways. We're going to see actually many ways. Let's skip this one. All right. Whoa. Okay. All right. Let's skip this one. Okay. Now I just want to talk a little bit about your friend. Is it Jaden or Clayton? What's his name? Sorry. Harry. Jaden. All right. So Jaden was doing factorizing. Okay, which actually is a good, it shows that he actually knows how to factorize things. Okay. But actually, he was thinking a little bit about this. You're already moving faster than us. All right, a little bit about that zero product property. Okay. Now the idea why sometimes we want to factorize is because if these factors are equal to 0, what does it mean? If A times B is equal to 0, what does it mean? It means that one of them is 0 or both of them could be 0. All right, so if you multiply anything by 0, you get 0. All right, so if you can factorize things, which is A and B, which is like x minus 2x plus 2, and it's equal to 0, then either one could be 0 or both will be 0. Okay, so whenever in math you say or, it's actually inclusive of both. Okay, so let's see an example here. And before we continue, why are there so many methods to solving an equation? Why? Why do you think there are so many methods? Anyone knows? Yeah.
Because there's so many different types of questions, right?
Yeah, man, because exams are tough, right? So, okay, because I mean, you can solve this, right? There are going to be many models that come up when you predict stuff. Your badminton, you play badminton? Okay, your basketball, all right? You're predicting whatever that flies. There will be many different types of equations. All right, so you need different kinds of methods. Okay, so I'm going to move a little bit faster because I do want to see this. All right, so I'm going to give you an example here of how we can do that zero product. What do you think we can do here? 4x squared minus 12x equals 0. What should we do? Factorize it. How do we factorize?
4x.
We take out 4x. And then what will be remaining there? X minus 3. So we get 4x and x minus 3 equals to 0. And remember, a times b is a times b. That means that either 4x is 0 or x minus 3 is 0. So the zero product property. All right, that gives me x equals 0, x equals 3. All right. Now, one cool thing you can do is that math, you can check your answers. So you know how much marks you get. All right. So one of the ways that you can check whether your answer is right or wrong, including that as well, is to substitute your answer into the equation. All right. So I got 0 and 3. Let's put in 0 here. Yes. Then I know 100% that this question is definitely correct. So you can check yourself. All right. So later, you don't have to wait for the answer. Just substitute that. Today, all right. Can you try part A to solve this? Ooh. So just now we did some factorizing. Let's see whether you still remember how to factorize this. All right, part B, never mind. All right, part B, I just want to let's do part A first, and then we see whether we can factorize it and we use that zero product property. Okay, and I still have some gifts. Okay, I want someone to come up to share. Those who have done you.
Must take it, okay? You must take it. I take mine. This is mine. There's the only thing is mine. You put it on my. Wait, I'm there.
I'm done. You're done? Okay, remember when you're done, you can check your answer. Substitute the x into your equation, see if you get 0. If you get, you're going to come up to the board to share. And someone who doesn't have a gift, alright, come up to the board. Anyone? You? Okay, both of you, come, both of you. Okay, you can do it one on this side again. You can do it on this side. And you can do it.
Hey, no, I'm just kidding.
Yeah, okay. You should be confident, correct? If you substitute your answer in, you will get it.
Let's go, Javan. Let's go, Javan.
Okay, you'll be the orange team.
Hey, what did he get?
X squared minus x. Well done. All right, everyone, give them a round of applause. Great self time. Thank you. Good job, good job. I think both of you reached the same answer. Okay, well done. Okay, so they both managed to factorize into x minus 4 and x plus 2. All right, then from there they get 4 and negative 2. And again, you can check your own answers, correct? So we can actually look and check the answers. So one way to check your own answers, you can see here. Well done, you can see. All right, after we factorize it, we can use our zero product property. We can check by substituting into the original equation. Okay, I wanted to show you guys part B because actually, if you have a graphing calculator, which you will use next time when you're in JC, is it called JC? Oh, JC, okay, JC. All right, you can actually plot this into it, and actually you can see where it intersects the x-axis. All right, so you don't have to solve sometimes. You just plot it there, you see index -2 and 4. All right, so there are many ways to check your answers. All right, helping you for your exams. All right, so that you don't have to worry about this. Okay, so I think time is up now. I'm going to end here. If you remember, you got a question of predicting that price. If you can come up with a good answer, all right, and share it with the teachers, I will share the answer with the teachers. Okay, then you can get the remaining price here. Okay, so please think about it. All right, as you go home. All right, talk to your friend. Okay, and earn this good price. All right, with that, thank you so much for joining me today and have a good science lesson. All right, I hope to see you guys again soon. All right, bye.
Thank you very much, Mr. Sean, and thank you guys for being very cooperative and also being engaging during the lesson. A last request, can all of you shift to that end so Mr. Vincent can grab a single photograph with all of us.